When you consume processed foods, your brain releases dopamine within 10 minutes, a neurotransmitter associated with pleasure and reward. Contrary to popular belief, this isn't just a simple sugar effect. A 2019 study in the journal Appetite found that the combination of sugar, fat, and salt in processed foods lights up brain regions more intensely than sugar alone. Your nucleus accumbens, a key part of the brain's reward system, responds similarly to highly palatable foods as it does to addictive substances. This means that the craving for processed foods is chemically akin to the craving for drugs, creating a feedback loop that encourages repeated consumption. Within 20 minutes of eating a processed snack, your blood sugar levels spike rapidly, triggering a cascade of insulin release from the pancreas. This rapid influx of insulin aims to lower your blood sugar, but it can lead to a subsequent crash, leaving you feeling tired and hungry again. A 2020 study in the journal Metabolism showed that these spikes and crashes are more pronounced with processed foods compared to whole foods. This cycle not only affects energy levels but also influences mood and cognitive function by causing fluctuations in glucose delivery to the brain. In the first 30 minutes after consuming processed foods, your brain's production of serotonin, a neurotransmitter that stabilizes mood, is altered. While serotonin synthesis is closely linked to the availability of tryptophan, an amino acid found in protein-rich foods, processed food consumption can interfere with its proper uptake. A 2021 study in Neuroscience and Biobehavioral Reviews found that diets high in processed foods lead to lower serotonin levels, potentially contributing to feelings of anxiety and depression. This interference with serotonin production highlights how processed foods can affect mental health, not just physical well-being. Many believe that processed foods merely add empty calories without affecting cognition. However, a 2021 study in the American Journal of Clinical Nutrition revealed that a diet high in processed foods can reduce hippocampal-dependent memory performance in just 4 weeks. The hippocampus is crucial for forming new memories, and its function is sensitive to dietary quality. Processed foods often lack micronutrients essential for brain health, such as omega-3 fatty acids, B vitamins, and antioxidants, leading to decreased cognitive functioning over time. This challenge to memory processing illustrates the profound impact of diet on brain health. Another common misconception is that processed foods only impact physical health. Yet, a 2022 meta-analysis in Frontiers in Psychology found a significant association between high consumption of processed foods and an increased risk of depression. The alteration of gut microbiota by these foods can affect brain health through the gut-brain axis. When you consume processed foods, they can disrupt the balance of beneficial bacteria in your gut within hours, affecting neurotransmitter production and mood regulation. This gut-brain connection is a clear indicator of how processed foods influence not only your physical state, but also your psychological well-being. Inside you, the enzyme amylase starts breaking down carbohydrates from processed foods in your mouth, long before they reach your stomach. As these carbs are rapidly digested, glucose floods your bloodstream. In response, your pancreas releases insulin to facilitate glucose uptake into cells. A 2018 study in the Journal of Clinical Endocrinology and Metabolism demonstrated that excessive insulin can lead to receptor desensitization over time. This means your cells become less responsive to insulin, increasing the risk of type 2 diabetes. This metabolic strain is often hidden beneath the immediate pleasure of consumption. Processed foods influence your brain's reward circuitry, especially through the neurotransmitter dopamine. A 2017 study at Princeton found that rats given sucrose showed dopamine surges in the nucleus accumbens nearly identical to morphine exposure, peaking within 20 minutes of ingestion. This dopamine release reinforces the desire to consume more, creating a cycle of reward-seeking behavior. Repeated exposure can lead to downregulation of dopamine receptors, requiring higher intake for the same pleasure. This biological adaptation can increase the risk of overconsumption. The gut-brain axis plays a critical role in how processed foods affect mood and cognition. Soluble fibers reach the colon intact, where they are fermented by gut microbes into short-chain fatty acids like butyrate. However, processed foods often lack these fibers. A 2019 study in Cell Reports showed that butyrate can cross the blood-brain barrier and influence brain function by modulating neurotransmitter levels. Without sufficient fiber, the production of butyrate decreases, potentially leading to increased inflammation and mood disorders. This gut-brain connection underscores the impact of diet on mental health. When you consume processed foods, your liver is tasked with detoxifying artificial additives. One common preservative, sodium benzoate, needs to be metabolized into hippuric acid. A 2020 study in food chemistry noted that this process requires glycine, an amino acid also used for neurotransmitter synthesis. High intake of such additives can divert glycine from its role in neurotransmission, affecting mood regulation and cognitive function. This biochemical demand can subtly alter brain chemistry without immediate symptoms, illustrating how processed foods can silently influence mental processes. The interaction between emulsifiers in processed foods and intestinal bacteria is another hidden mechanism. Emulsifiers such as polysorbate 80 and carboxymethylcellulose can disrupt the mucosal barrier. A 2015 study published in Nature found that these additives alter gut microbiota composition, promoting inflammation. This inflammatory response can reach the brain, influencing mood and cognitive function through the release of cytokines. The disruption of gut homeostasis by such additives highlights how processed foods can extend their impact beyond digestion, affecting the brain's biochemistry and potentially contributing to neurological disorders. Consuming processed foods in excess can lead to chronic inflammation, affecting the brain over time. A 2019 study in the Journal of Neuroinflammation highlighted how diets high in processed foods exacerbate neuroinflammatory pathways. This inflammation is linked with cognitive decline and even neurodegenerative diseases. The body's immune response can become overactive, promoting pathways that damage brain cells. Long-term exposure to these foods contributes to the gradual degradation of neurons. The effects are not immediately visible but build up over years, emphasizing the hidden risk processed foods pose to brain health. The long-term effects of processed food consumption on the brain can be severe. A 2022 study in molecular psychiatry found that individuals consuming high amounts of processed foods had a 33% higher risk of developing depression over 5 years, compared to those with minimal intake. This correlation is not just due to nutrient deficiencies but also the neural impact of chronic overconsumption, which alters brain structure. Prolonged exposure can lead to thinning of the cortex, the area responsible for higher cognitive functions, affecting everything from decision-making to emotional regulation. Food companies often engineer products to exploit your brain's reward system, creating foods designed to be irresistible. A 2021 analysis in the journal Obesity Reviews revealed that many processed foods are optimized for hyper-palatability, a combination of fat, sugar, and salt that maximizes pleasure signals in the brain. This engineering increases the likelihood of overconsumption. The addictive potential of these foods is comparable to that of nicotine, with similar neurological pathways activated. This manipulation underscores the industry's awareness of how to keep consumers hooked, often at the expense of long-term health. In cases of extreme consumption, processed foods can lead to insulin resistance, affecting your brain's ability to utilize glucose efficiently. A 2020 study in the journal Diabetes found that chronic high intake of processed foods impairs the brain's insulin pathways, leading to cognitive deficits. Insulin isn't just for blood sugar regulation, it also plays a role in neurotransmitter production. When insulin signaling is disrupted, brain cells struggle to communicate effectively, leading to issues with memory and learning. This demonstrates how metabolic health is deeply intertwined with neurological health. Here's a staggering fact. A 2018 meta-analysis in the journal Aging showed that people who reduce processed food intake significantly can decrease their risk of developing Alzheimer's disease by up to 45%. This is due to the reduction of inflammation and oxidative stress on neurons. Processed foods often contain advanced glycation end products, or AGEs, which accumulate in the brain, promoting neurodegeneration. By cutting back, you allow your brain to maintain its structural integrity longer. This fact reframes processed foods not just as dietary choices but as key players in your brain's future.